imagination. And so here you're showing a whole bunch of 3D demonstrations. So what is it that you do?
Well, we supply the IP to our silicon partners, the chip companies like Intel, Texas Instruments, Renesas, that sort of company. And what we're showing here is a selection of 3D graphics-enabled application processors. Now, these are mostly aimed at the mobile handset market, except in one case, which is aimed at the set-top box consumer market. So, this dev kit here is an OMAP 4, which is running an SGX 540, and it's demonstrating here that it has dual screen capabilities, so it runs the application. It has the ability to drive an HD screen, either front or back.
Does it work if I touch?
I think it's actually stopped.
Down here? Okay. It's demo.
It's just demo.
Yeah? A dual 3D.
Do you know how to get this demo kicked off again? It seems to have stopped.
Oh, it seems to have stopped, yeah. So it's quite new hardware, so let's see if we just...
There you use some...
Hold it for a couple of seconds.
Plug it back and then it's going to boot. What kind of OS is it going to boot?
So it's standard Linux. So you should get some penguins up there.
The penguins are going to come? And is it going to be super long boot or is it
No, it's fairly short.
very short? And then, so when you have the penguins, when you have Linux, and what else is there to get your technology working? What are you making, drivers, or what is that your technology is?
The graphics technology responds to the OpenGL ES 2.0 API. So what you need is a library which accesses that hardware. That's our graphics driver stack.
So if you have hardware acceleration for 3D, you are enabling 3D.
That's correct. So we provide the hardware. The hardware provides a set of functions. In this case, all the functions are programmable. In order to invoke those graphics functions, you need to have the API enabled, which is what our driver does for you. Our driver is essentially a library which accepts calls from the application, and then it invokes the hardware to accelerate those calls. And then the hardware renders into a piece of memory, and that's picked up by the frame buffer controller and streamed out onto the screen. That's the process end to end.
Nice.
So in order to enable the 3D, you need the two components. You need the hardware, which can accelerate it. You need the API stack, which accesses the hardware, and then of course you need some content. So you need to have some tools which enable you to build the content, which will run on the CPU and drive the display.
So right here is OMAP 4. And this is OMAP 3, right?
That's OMAP 3, yes.
And could you say something about what the 3D, how has it improved between the two?
Well, between the two implementations, the 3D is approximately doubled in performance. So the OMAP 4 contains an SGX 540, and the OMAP 3 contains an SGX 530. The SGX it's a programmable machine with shader pipelines, and the easiest way to think about the difference in performance is that the SGX 540 has twice as many pipelines as the 530. So because graphics is parallel, that means everything goes pretty much twice as fast.
So what if people want to play, let's say, Unreal Tournament on these kind of devices? Does it have anything to do with your technology?
Well, these devices really don't have the performance to play Unreal Tournament at a reasonable frame rate with a large screen, right?
Okay.
These are intended for mobile devices. Now they're getting more performant. The actual performance of the hardware is excellent for the power profile, right? But these particular implementations wouldn't really give you a good experience on a large screen with a game like Unreal.
But you would be enabling that experience if there is Unreal Tournament.
Yes, and our development roadmap shows us building cores which are based on the 540 or the successor to the 540, which we call the 543, which is twice as powerful. And then we have got a multiprocessor variant of that, which puts together up to 16 cores, which is a total of 64 pipelines. And now you're starting to get into the territory of being able to play a game like Unreal.
All right.
But you wouldn't see that on a mobile handset this year.
Can we go over there?
Sure. Phones? Sure.
Because on all these small phones, could you explain what's going on and what are you doing here?
So this is some of our history on the bottom shelf here.
Yeah.
So these phones have been out for quite some time. You can see you've got one here from Samsung. which is showing our video decoder. The next one along here, the Sony Ericsson, is got an MBX, which is an older API, which is a fixed function 3D graphics API. And similarly with the Nokia N93 and the original iPhone 3G, that's the OpenGLES 1.1 fixed function API. If you come up to this next level, this is the newer API, similar to what we saw earlier. This is SGX, and this is the programmable API that I described earlier. So we've got this Samsung phone from Vodafone, the 360, a Nokia N900, and then the iPhone 3GS at the top here. And these are all running the SGX. Now, this application, which is running on the 3GS, is something which was written for us by Digital Legends. And it's an app which is intended to show off all of the functionality that you can get from this new programmable API. It runs beautifully on the handset like that, and it shows things like it shows you reflections. It's showing you the water, the caustics, and the refraction. All of these effects that you can get with this new API.
So it's enabling a whole lot of new games.
Exactly. If you take a look on the big screen here, this is the same application, and this has been frame captured from a higher end device. So it's an unused higher end device that we've got on. So you can see with the larger screen, you get a better idea of the quality of the 3D graphics.
What kind of computer is that? Is that a on-card?
It's a consumer level device. It's not a computer.
It's not a full computer.
It's not a full. Well, it is a full computer, but
Yeah,
you wouldn't recognize it as a
yeah.
PC. It's not a PC,
Okay.
and it doesn't have a plug-in card. It's an integrated graphics.
Okay.
And it's a consumer device which has not yet been released.
All right.
And it's just a
Okay.
higher end than we
And it's somewhere behind
It's in the base.
the base. And could you? So up here, those are basically they're called ARM Cortex A8. Is that what it is?
Well, these
Up
vary.
there?
These chipsets vary.
Yeah.
If you take a look, so this is a Sony Ericsson phone, which has got they've got a processor in there, which was their choice. I'm not sure which one it is.
Yeah.
This is the Droid, the Motorola Droid. It's called the Milestone in England,
Yeah.
and this has a Cortex A8 in it, which is the OMAP 3.
Yeah.
The iPhone has a CPU in it, which I don't actually know what it is, but it's
The
a similar
Apple
class.
something.
It's an Apple designed chip. Right. So they've got a variety of CPUs in there.
And then you power also the Intel powered devices.
Right. So this is an x86, an Atom.
And this one is something else.
This is that is an SH processor from Renaissance.
SH.
Yes.
So it's not ARM.
It's not on.
Something different.
Yes, it's we work with any processor. We have implementations with MIPS. We have implementations with all sorts of processors.
Cool. So and when there is Unreal Tournament, you're powering it as well. You're powering everything that has
when it comes
3D.
onto, yes, of course, yes.
Cool.
Yes.
And there's many interesting things coming.
Many interesting things coming. All sorts of. Take a look at our partners' stands here. You'll see navigation apps, which are targeted towards the handset, but they're just as applicable to consumer devices like set-top box. What you'll see in the next year or so is 3 or 4 companies coming out with set-top box chips, which have got full 3D graphics. So you're going to have a scrolling user interface, programmable program guides, EPGs on your set-top box.
Is it anything to do with what NVIDIA is doing?
They're attempting to enter the same
work with
market.
them? Or you
No.
competing?
Well, our customers compete with NVIDIA.
Okay.
Our customers compete with NVIDIA.
That's hard.
Yes.
And but you're the biggest right now.
We're the biggest in the mobile
embedded market.
handsets. Yes, in the embedded.
All right. And so you wouldn't say that a small device like this could replace like a game console?
Well, yes, it will very shortly.
will,
yes.
very shortly.
Yes, because what people it'll never replace the very big high-end console where you want to develop the biggest and most expensive games. But people are turning to handsets like this to play their games. And you can always plug all of these devices. You can plug them into a television set. They mostly have HDMI outputs, so you can drive an HD screen with these guys.
But it's not like a PS3, but it's maybe like a Wii.
Yes, these things are
graphics
These
quality.
things are as capable as a Wii,
Yeah.
and the graphics capability is getting higher and higher year on year. It's more than doubling every year.
like the Wii is very popular. That's
The
good
Wii is
enough.
very popular.
So
Yes,
you've got
it's,
a console
It's
in
all
there.
about the game. It's
Yeah.
really not very much about the graphics.
All right. Okay.
Yeah.
Thanks a lot.